Okay, as I promised, I'm making this quick video. Maybe put it on 2x speed right now if you like. But this is another related rates. These are the practice related rates advanced on Khan Academy. The volume of a cylinder, okay. I'm pretty sure that's the base times the height, or for a cylinder is pi r squared h. It's increasing the volume at a rate of 10 pi cubic meters per hour. The height of the cylinder is fixed. Oh, okay, so the height is actually just 5 meters. And at a certain instant, they're telling us the volume is 80 pi cubic meters. What is the rate of change of the surface area? So we want to find the rate of change of the surface area over time at that instant. So that's when h is always 5 and v equals 80 pi. Okay, so let's think about this. So the surface area of a cylinder, I think they give us these equations down here. Oh my goodness, this equation, 2 pi r squared plus 2 pi r h. However, h is 5, so it'll just be 10 pi r, because 2 times 5, this would be 2 pi r squared. So when I take the derivative here, I would get the derivative of the surface area is equal to 4 pi r dr dt. I can't scroll over, so I'm going to write it below. Plus 10 pi dr dt. So I need to find what dr dt is also in order to answer this question, which I believe I could probably find by simply using this equation. Okay, we do know what r is because they're oh no, we don't know what r is, so it's telling us 80 pi equals pi times r squared times h, which is 5, so we can find r using the original equation. Divide that by pi. Oh, that's nice. Oops. Divided by 5, r squared equals 16, so the radius is 4. So I found one of the things I need to find the derivative of the surface area over time. R is 4, I don't know, I'm trying to keep myself organized, and then I need to find dr dt, which I think I could find because I know what the dv dt is, so I get dv dt. I'm going to differentiate this volume equation up top. Equals 2, well, it's actually, let me rewrite this equation because the height we know is 5. So that's 5 pi r squared. So let me erase this. Oh, that's an interesting eraser. Okay, so that'll be 10 pi r dr dt. We know dv dt is 10 pi. We know r is 4. So I can just see dr dt is going to be 1/4. So after all that work, I now have enough information to answer this question over here. Plug in the derivative of the surface area over time is equal to 4 pi times 4 for the radius times 1/4. Oh, well, those just cancel out. So it's just going to be 4 pi This times 4 times a quarter is 1, plus 10 pi over 4, which looks like it's simplified to 5 pi over 2. This is 8 pi over 2. If I convert it to like denominator, so that'll be 13 pi's over 2. Hopefully I didn't make any mistakes in all that time. Let's see if the answer is correct. Yes, it is. So let me just break down what I did. Essentially, we are noticing we need to use often two equations. One to find the basically just to find all the pieces of information that would allow me to evaluate what dSA dt is. So when I took the derivative of the surface area equation, I realized I had to know what r and dr dt is. Remember, for when you're doing these related rates problems, you always need to use the chain rule, because the r value is not just a value, it's a value that's changing over time. So that's why I needed to include, when I differentiated, I did 2r dr dt. So I had to also find dr dt using the volume equation by differentiating that. Of course, you may have found another pathway to get to the same solution, but this is the way I was able to. Hope this was helpful. Of course, I'm sure there's some related rates mentioned in one of the College Board daily videos. If you need some more practice, check that out. Or another student was telling me on AP Classroom they were watching those shorter lesson videos that often provide some practice questions as well. So you could sort through, I think this was applications of derivatives, that unit that you could find that. Have a great day and much love.